Good evening everyone. Welcome to my class. I am Sunita madam. Today I am going to teach one of the important topic in physics, that is superposition of waves. In the last class we studied in detail about sound waves. We solved few MCQ questions based on the topic sound waves. This today's class one of the most important topic, that is superposition of waves. Today I will explain the theory part. Tomorrow I will solve MCQ question based on the topic superposition of waves. Let us start the class. Those who are not there in the live, please see the recorded class. Those who are there in live, please attend the live classes. Okay. Okay, let us start the class. Superposition of waves. What is mean by superposition of waves? The principle of superposition says when two or more waves cross at a point, the displacement at that point is equal to the sum of the displacement of the individual waves. What is mean by superposition of waves? Means the waves, when they are traveling in a space, they will get superimposed, they will get mix each other. Okay. The name itself is indicating superposition or mixing up of two waves. When what is the principle of superposition of waves? When two or more waves cross at a point, when they will meet at a point, the displacement at that point is equal to sum of the displacement of the individual waves. Let us discuss that one in detail. What is mean by the superposition of waves? According to the principle of superposition, the resultant displacement of a number of waves in a medium at a particular point is the vector sum of the individual displacement produced by each of the waves at that point. When already I mentioned superposition of two waves, they may travel in the same position, they may get superimposed. Assume the two waves, like wave, consider this is wave y1, this is wave y2. When they are traveling in the same direction like this, y1, y2, both they will get superimposed at a point. At a point, both the waves, they will meet at a point, superimpose. Both also they will get superimposed at a single point. Then here the resultant displacement of the wave, it will be sum of the displacement of the two waves, y1 plus y2. Consider this is the wave y. The displacement of the wave y, it will be equal to sum of the displacement of the wave y1 plus y2. You have to remember what is mean by superposition of waves. Means when waves, when they are traveling in a space, they will get meet at a single point, they will get superimposed, they will get overlap on each other in the same direction. Sometime may in the same direction, sometime maybe in the opposite direction also they will get superimposed. Same direction also possible, opposite direction also they will get superimposed, means they will get overlap. Then here the resultant displacement means y, it will be equal to y1 plus y2, sum of the displacement of the two waves. Here y1 represent the displacement of the first wave, y2 be the displacement of the second y, then y, this is the displacement of the resultant wave. Therefore, the displacement of the resultant wave, it will be equal to sum of the displacement of the two waves. That one you have to remember. Very interesting and also easy topic. Someone they will get confused. Sorry. That's why in detail I will explain. Yes. Principle of superposition of waves. Considering two waves traveling simultaneously along the same stretch string in opposite direction as shown in the figure. Consider already I may explained superposition may be the waves they may travel in the same direction, they may travel in opposite direction. Here we consider two waves traveling simultaneously along the same stretch string in opposite direction. Yes, they may superimpose in the opposite direction also. Okay. We can see image of waveform in the stride at each instant of time. It is observed that net displacement of any element of a string at a given time is the algebraic sum of the displacement of each wave. Already I explained the resultant wave. Consider here one wave. Consider the displacement y1 x comma t. Then y2 will be x comma t. Then here the resultant displacement y x comma t, it will be equal to y1 plus y2. Resultant displacement of the wave, it will be equal to sum of the displacement of the two waves. That one you have to remember. Then hence the superposition of waves can lead the following three effects. Then we will study in detail. Already I explained what is meant by superposition of waves, intermixing of waves or overlapping of waves, any words you can consider. When two waves, when they are traveling in space, they will get superimposed, they will get overlap, they will meet at a single point, whether they are moving in the same direction, whether they will move in the opposite direction also, they will get superimposed. Then one more important thing you have to remember, the net displacement of the wave, it will be equal to y1 plus y2, displacement of the resultant displacement of the two waves. That one you have to remember. Whenever two waves having the same frequency travel with the same speed along the same direction, see I mentioned everything. Two waves have the same frequency, it will be same speed, it will be same. Then two waves, they are traveling in the same direction in a specific medium, then they superimpose, create an effect is known as interference of wave. Okay, what is mean by interference of wave? Don't get confused between interference of waves, stationary wave, beats, everything. I am explaining in detail everything. Okay, interference of wave means when two waves having the same frequency, it will be same and they will move at a constant speed, and also they are moving in the same direction. Consider two waves like this, y1, y2, they are traveling with the same frequency with same speed in the same direction, both also they will get overlap. That one we will consider as a interference of waves. Then next one, in a situation where two waves having similar frequency is same, move with the same speed also same, but they will move in the opposite direction in a specific medium, that one we will consider as a stationary wave. Always remember, stationary wave, the waves they will move in the opposite direction. Frequency is same, speed also same, but waves they will get overlap in the opposite direction. Means consider this is y1 wave, first wave, this is the second wave, both they will be in the opposite direction, they will get overlap, they will get superimposed. That waves we will consider as a stationary wave. Okay, then move to the next one. Finally, when two waves having slightly varying frequency travel with the same speed along the same direction in a specific medium, we will consider that one as a beat. Finally, two waves having a slightly varying frequency. This one is very important. Slightly varying frequency. If they are having two waves of almost same frequency, means we will get interference of wave. Two waves having little slightly varying frequency traveling in the same speed in the same direction, that one we will consider as a beat. There is a less difference between the interference of wave and also beat. In the case of interference of waves, what will happen? Frequency of two waves is exactly same frequency. But in the case of a beats, slightly varying difference. Maybe if one wave frequency is 320 hertz, another may be 340, like that. Slightly difference. Okay, slightly difference. But in the case of interference, frequency is exactly same. 320 means another wave also 320 hertz. These two very important. That one you have to remember. Then stationary wave, same frequency, traveling with same speed, but they will approach in the opposite direction. That one we will consider as a stationary waves. Very important topic today. I am explaining superposition of waves. I am requesting, please, those they are not in the live, please please listen the recorded class. At least please watch the recorded class. It will be helpful for you upcoming exam, whether it may be hstr, ctet, tet, gpstr, for all the type of exam. Definitely this is the one of the most important topic. Without knowing the concept, you can't answer any question, anything. Okay, next one, reflection of wave. We encounter situation involving the reflection of waves all around us. For example, in the phenomenon of echo, sound reflect from a distant object reaches the listener with a little delay. Yes, the echo sound it will travel in the form of a wave. Then even sound waves also, they will get reflect. Consider this is the pulse of a wave. Then consider this is a rigid object, maybe wall or something. When sound waves travel, when it will hit the object, then the incident wave, it will get reflected. Therefore that one only we will consider as a echo. Sound also, it will produce a echo. Sound waves, it will produce a echo because of the reflection of the waves. In this session, we will learn more about the reflection of wave from a fixed and also free end. Two types of reflection of sound waves we will study in detail. Fixed end and also free end. This one is very important. Carefully you have to listen. In the image shown below, we can see what happens when a pulse traveling wave encounters a rigid boundary. When this we will consider as a pulse. When one pulse, when it will hit the rigid object, what will happen? Consider this is the incident pulse. When it will reach the rigid object, again it will get reflected in the opposite direction. We see how under such a situation the pulse, the wave it will get reflected. Then here I listed few important points. When a wave is incident on any surface, when you incident the wave in any surface, the part of the incident wave is reflected, then remaining part it may transmitted. Assume if you are sending a wave, 100% of wave it will not get reflected. Only 90% of the part of the wave it will get reflected. Remaining 10% of the wave maybe it will get transmitted through the medium. If the wave is incident obliquely on the boundary, the transmitted wave can also be termed as a reflected wave. Okay, next one, here the incident and refracted waves obeys the Snell's law of refraction. You know Snell's law, sin I divided by sin R, it will be constant. In the case of refraction, only 50% of sound waves it will get reflected. Remaining maybe 50% it will get transmitted through the medium. Okay, here the incident and the refracted waves, both the waves, it will obey the Snell's law of refraction. You know Snell's law, it will be sin I divided by sin R, it will be constant. Then the incident and the reflected wave obey the law of reflection. incident ray and reflected ray in the case of law of reflection, otherwise the reflection process, it will obey the law of reflection. What is meant by law of reflection? Angle of incidence, it will be equal to angle of reflection. Then consider, I will write the figure here. Okay, this is the normal, this is the incident ray you can consider, or incident sound you can consider. This one everything I explained in the last class. Please watch the last class. Okay, this is the normal, this is the incident sound you can consider, this is the reflected sound, this is the angle of incident, this one is the angle of reflection, this is the normal drawn to the reflecting surface. Consider this is the reflecting surface. Then here this is the normal, angle of incident, angle of reflection, all the three they will lie on the same plane. That is the definition of a first law of reflection. Then the second law, it will tells angle of incidence, it will be equal to angle of reflection. That is the second law, it will tell. Coming to the next one, coming to the next point, the reflection of a wave or a pulse can happen from two types of surface. It can either be a fixed wall or a rigid, as shown in the image below. Already I informed here the reflection, it may happen fixed end reflection, and also one more type is there, free end reflection. Let us consider what is meant by a fixed end reflection. Fixed end reflection, we are having in the reflection two types. Only in the case of a sound waves we are having two types, fixed end reflection and also another one is free end reflection. Let us move to the next one, fixed end reflection. Name itself is indicating one of the end it will be fixed. Consider here, this is the incident pulse, here this one is the fixed end, here this end it will not at all move, the end it will be fixed, this end is fixed, therefore the name itself is indicating fixed end reflection. Let us consider the situation where a string is fixed to a rigid wall at its right end. When we allow a pulse to propagate through this string, the pulse reaches the right end, gets reflected as shown in the figure. Consider this is the pulse of a sound wave. When this pulse, when it will reach the fixed end, it will get reflected in the opposite direction. Inverted reflected pulse you can observe here. Let us consider one more point here. When the pulse arrives at the fixed end, when it will reach the fixed end, it exerts a force on the wall. When this pulse, when it will reach the fixed end, then it will exert a force on the wall. This is the rigid wall, it will exert a force. When it will exert a force on a fixed point, then there is no movement in the, there is no movement of the wave in this place because this end is fixed. According to the Newton's third law, the wall exerts an equal opposite force on a string. Here, this is the rigid wall, and also this point is fixed. Therefore, there is no movement. But when this impulse, when it will hit the rigid wall at this point, this wall also in the opposite direction, means in this direction, it will experience a force. Okay, it will experience a equal and opposite force on the pulse. Therefore here the second picture you can observe, this pulse it will get inverted, ulta you can see, the pulse it will move like this, it will move like this. Once it will hit the fixed point, according to the Newton third law of motion, this rigid object, rigid wall, it will exert equal and opposite force in the opposite direction. Therefore, the pulse it will get inverted, it will move in this direction, in the opposite direction. This second force generates a pulse at the support which travels back along the string in the direction opposite to the opposite to that of the incident pulse. This is the direction of the incident pulse. This is the direction of the reflected pulse. Both the direction they will be opposite in direction. Why it will happen? Because here the one end of the thread you can consider, otherwise you using thread also you can do this experiment. One end it will be fixed, therefore this one we will call it as a fixed end reflection. Very easy one. One more point let us consider here. In a reflection of this kind, there is no displacement at the support as the string is fixed there. Here this point there is no displacement. This point it will not at all move, it will be fixed. Therefore there is no displacement of the string. The string it will not at all move. This wall it will exert a equal and opposite force in this opposite direction, but this string it will not move up and down. It will be fixed. There is no movement, there is no displacement of the wave. That one only here I mentioned, there is no displacement. The reflected and the next point, the reflected and incident pulse have opposite sign. Yes, both also they will move in the opposite direction, therefore they will possess the opposite sign. They cancel each other at that point. Thus in the case of a travelling wave, the reflection at a rigid boundary takes place with a phase reversal with a phase difference of pi. Pi means 180 degree. Almost the angle it will be 180 degree only, because this end is fixed. If the pulse if it moves in this direction, in the same direction, but here you will get the inverted pulse, but in the same direction it will come back. Therefore the angle, otherwise phase difference, it will be 180 degree. Very important. They may ask in the MCQ question, in the case of a fixed end reflection, what is the phase difference? They may ask. The phase difference it will be 180 degree. Okay. Coming to the next one. Next one, free end reflection. The name itself is indicating free end reflection. What is mean by free end? Free end, here you can see this thread is tied here. Consider this is a wall. This is the free end. Free end means it can move even up also. It can move even down also. There will be a movement. It can move up and down. Free movement is there. Therefore, the name itself is indicating free end reflection. But in the last what we discussed, that is fixed end, there is no movement at this point. But here the free end reflection means there will be a movement. Free end reflection, when the right end of the string is tied to a ring which slides up and down without any friction on a rod. Yes, it can move up and down without any friction. Consider this is a rod, then this one at this point the string otherwise string, when the right end of the string is tied to a ring, which this is the ring, this one is the ring, this is the string. Okay, string or wire you can consider. This one is the ring, then this is the rod. When you insert the ring inside the rod, then you can see the movement of ring up and down inside the rod. Okay, we term it as a free end reflection. We can consider this one because easily it can move up and down. Therefore, free end reflection we can consider. In this case, when the pulse arrives at the right end, the rings moves up the rod. As it moves, it pulls on the string, stretching the string, producing a reflected pulse with the same sign and amplitude as the incident pulse. You can observe here this is the incident pulse. This is the reflected pulse. Both amplitude it will be same. Amplitude is nothing but height of the wave. This is the height of the wave. Amplitude it will be same. And also see the direction, they will be opposite. Here the pulse same sign means the pulse is not inverted here. In the free end reflection, the pulse is not inverted, but in the fixed end reflection, this is the incident pulse, this is the inverted reflected pulse. Here the pulse is inverted in the case of a fixed end. Therefore, here you are getting a opposite sign because inverted pulse, no, that's why both the direction is opposite. But here the pulse is inverted, therefore you will get the opposite sign. But what will happen in the case of a free end reflection? What will happen in the case of a free end reflection? You can observe here. Here this is the incident pulse, this is the reflected pulse. Then here both also the pulse it will not get inverted. It will be in the same direction. Okay. It will be in the same direction. This is the incident pulse, this is the reflected pulse, this is the movable free end of the reflection. Let us consider the points. What will happen in the free end reflection? Thus, in such a reflection, the incident reflected pulse reinforce each other, creating the maximum displacement at the end of the string. Here it will create a maximum displacement. But in the case of a fixed end reflection, there is no displacement. That one you have to remember. In the case of free end reflection, you can observe a maximum displacement. Okay, that one you have to remember. The maximum displacement of the ring is twice the amplitude of either of the pulse. Displacement is how much? Displacement is maximum, that it will be 2 times of the amplitude. Okay, displacement it will be 2 times of the amplitude. That one you have to remember. Thus, the reflection occurs without any additional phase shift. In the case of a traveling wave, the reflection at an open boundary, the reflection takes place without any phase change. Okay, here there is no phase difference. Last time I told the phase difference it will be 180 degree in the case of a fixed end reflection. But here in the case of a free end reflection, there is no phase difference without any phase change. The reflection occurs without any additional phase shift. Phase it will not at all shift. In the case of a traveling wave, the reflection at an open boundary. This one is the open boundary, free movable boundary. The reflection takes place without any phase change. But in the case of a fixed end, the phase change it will be pi 180 degree. Why I am comparing both also means when you are reading, you have to remember, you have to compare, then only easily you can remember. Next one, coming to the next one, standing wave. Yes, standing wave, also stationary wave. Standing wave, stationary wave, both also same. Combination of two waves moving in opposite direction, each having the same amplitude and also frequency. Already I explained what is meant by a stationary wave. Otherwise, what is meant by a standing wave. Both the words also same. Don't get confused between both. Standing waves and stationary waves, both also same. Two waves, when they will move in the opposite direction, having same amplitude and frequency, then you will get a stationary wave or standing wave. Consider wave, one wave is moving in this direction, another wave is moving in this direction, both they will get superimposed. Then you will get a standing wave or a stationary wave. The phenomenon is the result of interference, that is, when waves are superimposed, their energies are either added together or cancel out. Sometimes the energy it may added together, sometimes it may cancel out. Okay. Yes, here I mentioned one more diagram neatly. Consider two waves. One wave is moving like this. Consider the pink wave is moving like this. Blue wave is moving in the opposite direction. Then you will get the resultant wave, superimposed wave, the dotted one. Okay. Then both also they will get superimposed. Y it will be equal to y1 plus y2. Displacement of the superimposed wave, it will be sum of the displacement of the two waves. That one you have to remember. Next very important point, nodes and also antinodes. This topic almost it will take 1 hour, maybe more than 1 hour also it will take, but I have to complete the concept. Tomorrow we will discuss MCQ question based on this topic. Yes, what is meant by nodes and also antinodes? Consider this is a single wave. Consider this is the single wave. What is mean by wavelength? The distance between the two successive, whether it is a crust or trough, we will consider as a wavelength. From here to here, from here to here, we will consider as a wavelength. Okay, wavelength. What is mean by node and antinode? Consider this point, we will consider as a node. These point, this one, this one, this one, this one, we will consider as a node where amplitude is 0. Amplitude is 0. Antinode means where amplitude is maximum. Amplitude is maximum. That is the meaning of node and also antinode. Always remember, in the case of a node, amplitude is 0. In the case of an antinode, amplitude is maximum. A node is a point along with a standing wave where the wave has a minimum amplitude. Minimum amplitude or 0 amplitude also you can consider, but we will not consider 0. Better consider minimum only. Consider that word, that only it is properly, it will. Okay, amplitude is minimum. Antinode means amplitude it will be maximum. The opposite of a node is antinode, a point where the amplitude of a standing wave is maximum. This occur midway between the nodes. Okay. Yes. The distance between the two successive node is lambda. Then the distance between, yes, this one we will consider as even wavelength also. Yes. Next one, the distance between the two successive nodes we will consider as lambda. Then the distance between the two nodes we will consider as lambda by 2 of the wavelength. Then the distance between the node and antinode, from here to here, node and antinode, the measurement it will be lambda by 4. This one you have to remember. You know the meaning of wavelength, the distance between the two successive nodes, that is wavelength, lambda. Then the distance between the two nodes, the distance between the two nodes, it is lambda by 2. Then the distance between the node and antinode, from here to here, no, this is the antinode, this is the node. The distance between the antinode and node is lambda by 4. This one you have to remember. Okay. Otherwise I will explain one more time here. See, from here to here we will consider as a wavelength lambda, the distance between the two successive nodes. Then from here to here, the distance between the two nodes is lambda by 2. This node, this antinode, this antinode, the distance between node and antinode is lambda by 4. That one you have to remember. Okay. Yes. Next one. What is meant by a standing waves? Nodes and antinodes, one more time I mentioned here. Yes, I will move to the next one now. What is the characteristic of the standing waves. Let us study here. Standing waves are characterized by nodes and antinodes. Yes, we will characterize standing waves based on the nodes and antinodes, where nodes having minimum amplitude, antinodes they will possess the maximum amplitude. That one you have to remember. The amplitude of vibration of the particle is maximum at antinodes and minimum at the nodes. The vibration within a string can produce a variety of pattern. Each pattern corresponding to the vibration takes place at a particular frequency. It is called as a harmonic. This I will explain what is meant by a harmonic. The lowest frequency at which the string vibrates to form a standing wave is called as a fundamental frequency or first harmonic. What is meant by first harmonic or fundamental harmonic means the lowest frequency at which the string vibrate to form a standing waves. You know, standing wave means two waves having the same frequency, same speed, they will get overlap, you will get a standing waves. Whether it is a interference of wave, beat we will get, then three types we will get. But when two waves having the same frequency with same speed, when they will get overlap, we will get a standing wave. Then at a minimum frequency, they will get overlap. Lowest frequency, we will get overlap. That one we will consider as a fundamental frequency or first harmonic. Like first wave, we will get, no, first wave it will get. When two waves, when they will get superimposed, then they will form a first wave like this, no. I will write properly. First wave, that one only we will consider as a first harmonic, like this first wave, like this first wave, one wave, then the second wave like this, they will get overlap, no. This is the third wave like this. This is first harmonic, we will consider second harmonic, third harmonic. This I will explain in detail what is meant by harmonic. The wavelength and the speed of the wave determine the frequency of each harmonic. How you will get the harmonics? Harmonics means rhythmic. You can observe in the musical instruments, those they are playing the guitar, flute, everything. You can observe the superposition of wave or overlapping of sound waves, it will takes place. Then here the harmonics they will get produced continuously, because you have to listen a rhythmic pattern, no. That's why. But what is meant by fundamental frequency, you have to remember the lowest frequency at which the string it will get overlap. Nodes and antinodes, everything I explained here. See here, antinode is used to describe the point of maximum vibration. You can consider maximum amplitude, you can consider both also same. Is a place where the medium is having, medium does not move, medium it will not move, otherwise the medium it will not vibrate, amplitude it will be minimum, anything you can consider. Okay, next one, this class I will take 1 hour, within 1 hour I will complete. Next one, open end or antinodes for air columns. Consider this is the air column means we will get air columns. One is closed air column also we will get, where two ends are open. Here first case, here consider first case, both the ends also open. This is the both the ends also open. This one we will call it as a air column. Air column is nothing but a hollow tube. Inside the hollow tube, here the air is present. Then inside the air column, the two waves they will get superimposed, then they will get the harmonics. Here you can, how many nodes and antinodes it will form in the case of a open air column. This also, this side also open, this side also open. Everything I given theory part you can read. Even I will give, I will provide PDF notes also, make use of that one. Then here at the open end you will get a antinode. This is the antinode at the open end. At the middle you will get the node. Antinode means where the amplitude it will be maximum, at the node the amplitude it will be minimum. Using pictures, seeing the picture only you can recognize, that one you have to remember. Okay, this is the open end air column. Air column means Here hollow tube, inside the hollow tube air is present, like flute. Those who are musical instrument flutes, you can observe both the ends also open. Then another one is closed one, closed end, another one is open. Here you will get the node at the closed part, you will get the node. Open part you will get the antinode. Always when the ends are open you will get the antinode. When ends are closed you will get the node. Node means minimum amplitude, antinode means maximum amplitude. That much you have to remember. Yes, first harmonic, second harmonic I told no. This is the first harmonic fundamental frequency you can consider. This is the second harmonic. You can observe the two waves it will get generated. This is the third harmonic. Air column, everything I explained in detail, but I will read fastly. Okay. Air column can be found in various musical instrument. Yes, even flute, flute, any mouth organs, everything it contains a air column. Air column can be found in various musical instrument where it is enclosed with a hollow metal tube. Hollow, it contains inside air. To conserve space, it is coiled upon itself several times. It is almost nearer to 1 meter in length. What is the length of the air column? Almost it is 1 meter. Suppose if the end of the tube is left uncovered, if it is open, thus allowing the sound waves to reach it, then that end is termed as a open end. If the end is not closed, simple, that is the open end. Various musical instrument operates on the mechanism of the open end air column, that is when the end of the tube is completely uncovered. Completely uncovered is open, like flute, mouth organs, like that. Next one, suppose if one of the end of the tube is left uncovered in the surrounding atmosphere and the another end of the tube is covered, that is termed as a closed air column. Closed air column means one of the end is closed, another end is open. That is one we will consider as a closed air column. For example, some pipe organs and their column that is comprised with the orchestra. It is possible to convert open tube air column to closed tube air column. Close one of the end, then it will become closed tube air column. Standing wave, let us discuss few more characteristic of a standing wave in the air column. Always remember what is meant by air column. Hollow tube, inside the hollow tube is filled with air. Sometime both the ends also open, sometime one end it will be closed. If one end is closed, that one we will consider as a closed end air column. It is a physical phenomena where it provides sound and resonance in wind instrument. What is the use of the standing waves? It will gives a rhythmic movement of the sound waves, then it will set up a resonance, then that one we will help, it will be helpful for the musical instrument. The standing wave present in air column is nothing but a longitudinal wave, transverse wave. Standing waves is a combination of both longitudinal and also transverse wave. Standing wave can be defined as a wave that remains ideal or constant position. What is meant by longitudinal wave? Is parallel to the direction of the wave. Always the wave, it will travel parallel to the direction of the wave. Transverse wave, it will travel along the direction of the medium. A longitudinal wave is parallel to the direction of the wave. Parallelly, it will move. Longitudinal wave. Transverse wave can be defined as a wave where the flow of particles in a medium is directly perpendicular to the direction of propagation of the wave. Always remember, longitudinal wave, the propagation of the particles, it will be parallel to the propagation of the wave. But in the case of a transverse wave, the vibration of the particles, it will be perpendicular to the vibration of the otherwise direction of the propagation of the wave. Consider here air column I told no. Air column, one is open end, another one is closed end, both also open, both also closed. Three different way also we can use. When there is a formation of a sound waves in a tube, the motion is ungowned. This is at the antinode, open node. Always in the open you will get the antinode. Already I told maximum amplitude you will get in the open node. There will be a maximum displacement, maximum amplitude, everything it will happen. At the node, closed node, otherwise closed part, there will be no displacement and also that end is blocked. The distance from a closed end to the open end is equal to the 1/4 of the wavelength of the total wavelength. 1/4. I told no, lambda by 4. The distance between the node and antinode, it will be lambda by 4. I showed here, otherwise I will show one more time here. Already I showed that one. Here, listen here. The distance between the node and antinode, it will be lambda by 4 or 1/4. They are telling. That's why what I will explain each and everything is important. Someone you will feel bored why ma'am is taking 1 hour continuously means you have to understand the concept. Without concept you can't answer any questions, whether it is a multiple choice question, whether it is a direct question and answers, nothing you can answer. Okay, yes, we will move to the next one. Few more characteristic of a standing waves I listed because you have to easily you can remember. The standing waves are stationary. Yes, the disturbance does not travel in any direction, constant. Standing waves have points to 0 amplitude, that one we will consider as a node. Maximum amplitude we will consider as a antinodes. Already I explained in detail. There will not be any flow of energy across any section of the medium. In the stationary wave, there is no flow of energy. Flow of energy is restricted. The distance between the two consecutive nodes and antinode is lambda by 2. The distance between the antinode and its adjacent node is lambda by 4. Already I explained that one in detail. The pressure change is maximum at the node, minimum at the antinode. Whether it is a pressure, amplitude, displacement, everything it will be same. The medium is divided into a number of segments. All the particles in a particular segment will vibrate in phase. Yes, every particle they will get vibrate in the same phase. However, the amplitude increases from 0 to maximum between the node and also antinode. Particles in neighboring segments vibrate in the opposite direction. Yes, when amplitude, otherwise vibration of the particles, it will be minimum in node, maximum in the antinode. You can see the variation in the amplitude, variation in the vibration of the particles also. Everything it will be important. The period of oscillation of any particles in the medium is same as that of the component waves. The period of oscillation. The period of oscillation is nothing but for one complete oscillation. The time, how much time it will take to complete one oscillation, that is nothing but a time period. How much time it will take to oscillate any particle in a particular medium, that we will consider as a time period of a wave. Next, last topic, fundamental frequency and what is meant by a harmonics. The lowest resonant frequency of a vibrating object is called as its fundamental frequency. Yes, already I told the lowest frequency when two waves, when they will get superimposed. At the beginning of the superimpose that process, the minimum frequency required by the two waves, that is nothing but fundamental frequency. Once the frequency is adjusted, then you will get the rhythmic movement of the wave. The rhythmic movement of the wave we will consider as a harmonics. First harmonic, second harmonic, third harmonic, like that we will get. Most vibrating objects have more than one resonant frequency, and those used in musical instrument typically vibrate at harmonics of the fundamental. Harmonics means the sound waves, once they will achieve the fundamental frequency, they will start vibrating with the rhythmic harmonics. Okay, rhythmic frequency or rhythmic amplitude, with same amplitude frequency, rhythmically they will be vibrating. That one we will consider as a harmonic. What is the definition of harmonic then? Harmonic is defined as an integer or whole number multiple of the fundamental frequency. Vibrating string open, whether it is a vibrating string, open cylindrical air column, conical air column, will vibrate at all harmonics of the fundamental. Yes, see here, once the fundamental frequency is reached, consider n is the fundamental frequency, nf is the fundamental frequency. Nf, if n is 1, we will get first harmonic. If n is 2, we will get second harmonic. N is 3, we will get third harmonic, like that. I will show here, you can observe here. Okay, see, consider this is the fundamental frequency. Once again I will explain what is meant by harmonics. An ideal vibrating string will vibrate with its fundamental frequency. All harmonics that frequency, the position of the nodes and antinodes is just opposite of those for an open air column. Consider when superposition of waves, when it is takes place, then only when it will achieve a fundamental frequency. Consider this is the fundamental frequency, you can observe here. Then here, once it will achieve the fundamental frequency, the next case it will produce a harmonics, means number of waves it will be increasing, but that waves they will vibrate with the same frequency. Okay, you have to remember the formula. F, it will be mu divided by 2L. Mu means waves on string. Wave on string, how you will get? Square root of T divided by M divided by L, where T is the string tension, M is the string mass, L is the string length. This is the higher one, you have to remember. Okay, few more points here. Cylinders with one end closed will vibrate with only odd harmonics. Yes, cylinders, consider this one, we will consider as a cylinder. Okay, here they are telling the important one, cylinder with one end closed. If one end is closed like this, another end is open, then here you will get only hard harmonics. Hard harmonics means 1, 3, 5, 7, 9, like this we will get odd harmonics. N may be, N it will be here odd number. See here, nth harmonic, N into fundamental frequency is the fundamental frequency, no? Then here n, then value of n it will be 1, 3, 5, 7, 9. This it will be, this it will, you can observe only if one of the end is closed, another one is open. Vibrating membrane typically produces vibration at harmonics, but also have some resonance frequency which are not harmonics. Always musical instrument, they will be not produce the sound always. It may be harmonic sometime it may be not harmonic. Okay, it is for this class of vibrators that the term overtone becomes useful. They are said to have some non-harmonic overtones. Even we will get some of the non-harmonic overtones also. Then here nth harmonic, how you will get? N into fundamental frequency. When n is 1, first harmonic, n is 2, second harmonic, n is 3, third harmonic, like that. I included here. See, you can observe. When n is equal to 1, first harmonic, n is equal to 2, you will get 2 harmonics. N is equal to 3, 3 harmonics. N is equal to 4, 4, 5, 6, like that. Okay, I think today class is helpful. In detail, everything I explained. Superposition of waves, very interesting topic. In physics, what you have to do, you have to understand the concept. Once you understand the concept, it will be useful for you, it will be helpful. Whether they will ask the difficult question, easy question, if you know the concept easily you can answer, whether it is in hstr RTET, CTET, gpstr, everything. If you know the topic, if you know the concept, easily you can answer the question. That's why my request, before writing any competitive exam, thorough with your concept, whether it is any subject, physics, maths, whether it is psychology, computer, everything. First you know the concept, first you know the subject properly, then try to solve the questions. Don't go directly to solving the multiple choice question. Don't go directly to solve the questions. It will be difficult for you. You will get confused. Especially in physics, don't solve multiple questions immediately without knowing the concept. First understand the concept, then try to solve the MCQ question. That's why I'm requesting those who are not there in the live now, please listen the recorded class, please watch the recorded class. Tomorrow I am going to solve MCQ question based on this topic. It will be very helpful for you. Okay, thank you everyone, thanks for listening my class. Okay, tomorrow evening at the same time I will take one more class. Okay, bye, take care.